In this video, we're going to take a look at how we can use a matrix to express the coordinates of a figure, and also how we can use a matrix to translate or slide a figure around. So you're used to listing coordinates, for example, as an ordered pair. So if I were to list the coordinates of point A in this quadrilateral pictured, I can see that if I count backwards 1, 2, 3, 4, the coordinates of point A would be -4, 0. Well, that's how you're used to expressing a coordinate, which is totally fine, but let's take a look at another way using matrices to do that. What we'll do is we'll set up a matrix that always has two rows. The top row of our matrix is going to be our x coordinate. The bottom row of our matrix is going to be our y coordinate. Each column of the matrix then is going to correspond to a different point. So, for example, point A, or the first column in my matrix, is going to be expressed as -4 and then 0. So it's well, not very different, but it is a different format from what you're used to. It's more of a vertical looking format, I suppose. Rather than having -4 and 0 next to each other, we have them above each other. But this is what we'll try to use to represent a matrix as coordinates. So let's continue it just as practice to find our coordinates. I can see point B is -1, +2. So in our new notation, we're going to list -1 in the top row and then +2 in the bottom. This would be a great time to pause the video and try to find the next two coordinates yourself. Hopefully you've done that. Point C is at 4, 1, so I'm going to list that as 4 and then 1, and then point D was at 3 and -1. So there's our new way to express these coordinates. Let's take a look at how we can express our rule using matrix notation as well. So here's what we've done in the past. We've done these two ways so far. We've first expressed translation slides as a verbal rule, which is what's listed up here. 4 units to the left, meaning we're going to move, well, obviously 4 to the left, and then we're going to move this figure also 2 units up. So that was the first way we described it, just as a verbal rule. Next up, we also described this mathematically. 4 units left means 4 units backwards, if we think of it. So we talked about expressing that as x minus 4. 2 units up, meaning we're adding 2 to the y value, so y plus 2. So that's all, again, old stuff we've talked about in previous videos. Our new stuff is down here. We're going to use a matrix notation as well to represent a translation. Since I want to move 4 to the left and the top of this represents an x direction, all I'm going to do is set up a matrix with -4 on the top. Since our second row, what we said would always represent our y, and we want to move up 2, I'll set up a matrix with 2 along the bottom. So we're going to start to see our rules now expressed this way. Let's go ahead and put all this together and use this matrix rule to translate a figure for our last example. Alright, so we're given a matrix representation of a triangle. I know this is a triangle for two reasons. One, well, duh, they've told me it's a triangle, but more so I can tell that there's 3 columns. Remember, each column is going to represent a different coordinate. I've labeled it A, B, and C just to help me graph this, and I've gone ahead and graphed at the bottom. If you need to graph this yourself, go ahead and pause the video and just make sure that your graph looks like mine. Remember, this matrix is saying that point A is at 1, 1. That's the notation that we're using. Okay. Next up, we have the rule given to us. Now, the rule is given to us as a verbal rule, 1 unit to the left and 3 units up. Now, of course, we don't need to use matrix addition to do this. I'm simply giving you another option as a way to translate an image or a pre-image. So we don't need to do it this way. If you like the other way, that's fine. I'm just giving you another option. So let's go ahead and see how this would work. Let's write a matrix rule that would fit for this translation. So I'm going to set up a matrix. If I want to move 1 to the left, that's in the x direction, and it's backwards, so I'm going to use -1 for the top of this matrix. I then want to move 3 units up. Well, that's a vertical direction, a y direction, and it's positive, so I'll put a +3 on the bottom. So that's my rule expressed as a matrix. Finally, the way that matrix addition will work, let me go ahead and set up my original pre-image matrix down here. That was 1 and 1, 5 and 0, and then 3 and negative 1. What I'm going to do is add my rule matrix onto this. Well, my rule matrix was negative 1 and 3. You may recall from the previous video, though, about adding matrices, we need them to be the same size. And so since I have 3 columns in the first matrix, I'll need 3 columns in the rule matrix. All I need to do then is go ahead and repeat that rule 3 times. If you had 4 coordinates, then repeat the rule 4 times. So what we have then, if you want to label these matrices, our first one is the preimage, where the figure starts out as. And again, you may want to do A, B, and C, so you remember what your coordinates were. The next matrix we just wrote was the rule matrix. We want to slide 1 to the left, so negative 1, and then 3 up, so a positive 3. Finally, then, to get the coordinates of our image, our answer, all we're going to do is add up those 2 matrices. We'll add elements in the same position together to get the coordinates of our image. So this, again, would be a great time to pause it. Why don't you do that? Go ahead and add all those elements together, and then why don't you go ahead and graph it as well? That would be a great way to check and make sure that we have done this correctly. So there are the coordinates I ended up with for the image. Notice I labeled the columns A prime, B prime, and C prime. Again, I simply did that by adding negative 1 to everything in the top and adding 3 to everything in the bottom. And then I've graphed as well. And notice in my graph, I've also labeled my points. I'm picky about that, so make sure your points are labeled. And then just to check that this was correct, did I move 1 unit to the left and 3 units up? Well, we can take a look. And yeah, that's absolutely what ended up happening. Point A moved 1 unit backwards and then 3 units up to become A prime. A beautiful representation of 2 triangles translated using matrices.